half of Gelade. My name is Katriona Thompson.
I'm Chris Falkenthal.
The other half is Yutaka, Kumagai and Bobby Comerford, who I'm afraid were not able to make it today. So we will be talking through, possibly quite slowly, Gelade. So in this day and age, modern bandaging suffer from quite a few issues. For example, they can get dirty really easily and need to be cleaned and redressed. And this, if the wound is severe enough, it has to be redressed by a nurse, and that's actually really time-consuming for them. Whereas with Gelade, you don't need that.
So there are a number of other competitions that are looking at the in theory stage and laboratory stage of using cells and growth factors to aid wound healing, but our bandage is going to be completely unique to theirs. Like, they're using human cells and just growth factors, while we will be using a living bandage. It's going to be actually even further. It's going to be a living first aid kit for wound healing using a unique ecosystem of living cells. So how's it going to work? So let's say you've got like a wound, an open wound, you don't want to get it infected, so you're going to apply one of our bandages. And so first you'll get our freeze-dried cells, add agar, the sterile water and saline, mix them together and you'll get our gel, which we'll apply to the wound. Then on top of that we'll go a biocompatible dressing such as alginate to hold it in place. Then our cells will become active. Some cells will start secreting cellulose, while others will start actually clogging the blood. The cellulose secreting cells that will cause the other ones to allow them to bind to it. Then actually for the other cells we're looking to use Gelade, it's going to be a colony of biogenetically engineered cells and viruses, and they need to fill a number of roles: to fight wound infection, to act as an anesthesis to numb pain, anti-inflammatory, and a biosensor telling you what's happening in the bandage. We're hoping to take from nature these activities by taking the genes for these functions that are already present in nature and inserting them into our bacteria cells. So I'll run through real quickly two of them. So bacteriophages, they were in the previous presentation as well, but this one we're going to use them to fight bacteria that infect wounds by modifying them to bind onto the most common bacteria that infect wounds to kill them. And then for the cellulose, we're using microbial cellulose, which is secreted naturally by certain bacteria. We'll have the other cells binding onto them.
Basically, there are many benefits to Gelade, such as accessibility and immediate treatment. And in the market today, a company for bandages, Johnson & Johnson, roughly sold $500 million last year. And so there's a real gap in the market for long-term sterile treatments, which Gelade would fit. As far as our packaging goes, we have three different products, which consist of a domestic use.
Yeah, a domestic use one, which is going to be actually a large package, and then a smaller keychain one for like just moving around mobily.
Oh dear.
And then we're going to have actually a large lab one for on the go to mix up your own bandages and apply them on as well.
So yeah, here's the keyring one on the right here in the green, and the domestic one. And then there's also a mini laboratory which would be able to culture your own cells.
Then the plan.
So our strategy plan would be basically we would, if we were to win, which is pretty helpful with this presentation, I'm sorry about that, we would hopefully go to Ars Electronica and iGEM and produce our exhibit.
We're going to look to work with leading members in the field that are based out of Trinity to get their feedback on the actual viability more further and how far away it is, because it probably is a long-term product developer on there coming up very soon. And then apply for a patent if there is actual great potential in this.
So 12 months down the line, we would actually be visiting companies and seeking advice and possibly funding in order to start lab trials and produce a somewhat prototype.
Which is going to be shown in exhibits to actually look at how the public generally react to buying a bio bandage and to engage the public more.
Eventually, we would have a fully developed exhibit which would hopefully show in galleries such as this one, and then we'd look into further developing our range with targeting areas such as scar tissue and
after wound surgeries, just applying this on, because the amount of time that nurses take up replacing dressings, there's a big potential there. And then for the exhibit itself, we want it to be as engaging as possible, so we're thinking of developing bacteria cells that will be different colours, and then the public can choose their cells and culture their own bandage and apply it onto a dummy hand, which will hopefully get across the whole theory of the bandage. Then we'll have like posters and packaging, which will engage the public as well about what's happening. That's pretty much it.
Thank you.
Where are your other team members?
Oh, sorry, we never actually said they actually both, one of them has to go on a lab, on a field trip, and the other one is got an interview that he wasn't able to get out of either.
So they had good excuses to leave you up there.
Yeah.
Excuses,
I'm interested that you have the presentation going forward, like a good few months into the future, about where the project would be planned to go. But iGEM was one of the things you presented. And iGEM requires, it doesn't take exhibitions, it doesn't take artistic merit as such, it tends to require a prototype. Given that, as you say yourself, it's unlikely you can produce a workable prototype of this within the iGEM timeframe, which is less than a year, what's the core function that you would choose to implement as an iGEM project that you think would sort of epitomize the overall goal?
Well, we'd like to look at the designing your own cells aspect a lot, to actually colouring the cells, and then also like the bacteriophages as well. That would be interesting to look at them more as well. And then clearly the cells where you can actually choose to what colours they're going to be by the pigments expressions.
So that would be a hit with kids to have coloured bandages. But, the bacteriophage would be your kind of
like staple, with antibiotic resistance building up.
Cool.
This is a novel way of treating infections.
Okay, thanks.